page 1. I'm on page 1, right after the pink cover.
They're so good.
Yeehaw! It's there. Page 1. So this second semester book, we're obviously going to explore further and further and further of when to know we have good data and when we don't. Okay, and how to analyze if it's good data or not. So, pretty quick lesson. So I'm on page 1 of second semester. All right. So this talks about large enough populations. Okay, so let's talk about something that takes place about every 10 years in the United States. They do something called the census. So what they try and do is they try and get every household, whether it's a house, whether it's an apartment, whether it's a trailer, whether it's even a homeless population, they try and gather information from 100% of the population of the United States. Okay? That's called the census. That way they can try and say, hey, can we offer different services to certain communities based on the census? Okay? So the census is 100% of the population. So, does the census sound like it'd be kind of hard to do as far as the United States? Yeah, there's a lot of people that when it comes to a census, everyone's going to say, oh, they don't have the right to ask me this or that. Okay? There's a lot of people do it. There's a lot of people on social media, because social media is now the norm of the day. They don't have the right to ask me how many television sets I have in my house. And like the census does all kinds of things. How many people live in the house? How many cars do you have? How many TVs do you have? How many bedrooms do you have? How many bathrooms do you have? What's your highest education? Things like that. That's what the census does. It's trying to collect data of 100% of the population. Okay, but I think you can all probably say that doing a census takes a lot of time, takes a lot of manpower, takes a lot of money. But it's something that the United States does every 10 years. Okay? But most other people will say, hey, do we have a large enough population that we can make conclusions based on our data that we pick? Okay? The census is going to give you really awesome data. Okay? But do we have enough of our population that's going to mean something? So, so a parameter is something that we'll talk about. A parameter is the numerical characteristic of an entire population. Okay? It's really hard to get to. But most of the time, parameters are unknown. Okay, so if I collect data and I want to make a conclusion based on my random data I collected, I have to have a certain amount, and my certain amount will then relate back to the parameter, which is the entire population. Okay? So that's just something. So on page 1, statistics are the numerical characteristics of the sample. Okay, statistics comes from the sample. Okay, so a parameter is everybody. The statistics that'll be done is on a certain amount of those people, a certain random number of those people or those items that we're trying to get statistics of. Like if we worked for Coca-Cola, you could sit there and go through the bottling line and check every can of soda that comes through your canning line to make sure that it has the right amount of soda in it. Or I could take a certain number of those cans off the assembly line, test it to see does it have the correct volume of soda in it. Okay? And there's ways that we can do that as a random population to say we're confident with our findings or we're not confident with our findings. Then they talk about we have a population mean. Population mean. And a population mean, we're going to use this Greek symbol. Okay? So this means the entire population. Okay? The population standard deviation. So population standard deviation, they are going to use this Greek letter. Okay, this is the standard deviation of the entire population, and this is usually kind of an unknown thing as well. But then you have the sample mean, which they will use X bar, and the sample standard deviation, they will use just S, a lowercase s. Okay, so when you see in a writing that they're using this information for the mean and the standard deviation, you have to realize it's coming from a sample. If you see these symbols, that means we're talking about the entire population, average or mean and standard deviation. Okay, so the standard deviation mean, the mean calculated directly from the sample. The standard deviation from the sample is calculated directly from the sample as well. If you were to use the TI graphing calculator, it always gives two standard deviations. It gives you what the standard deviation of the entire population would be, and it also gives you the sample standard deviation. Okay, so that's just something to go with, and there's an equation that he used in order to see if you can do that. So the question that parameters of all statistical research, do we trust our sample to represent the entire population? Okay, it's complicated, certain conditions are met, and the answer is yes. The conditions are as follows. So on page 2, starts talking about some of the conditions. Was random sampling done? Oops. Random sampling. Okay? Me as a person, I can't, if I walked into this classroom and says, I'm going to just pick people at random, I can't, as a person, pick people at random. Okay? If I were to walk in this room, I would say, okay, Reed, I'm picking you as a random person, and I'm going to pick Kiker as a random person, and I'm going to pick Laura as a random person. Okay? That does not mean that you are a random sample of this population of this classroom. Okay, I can't physically just select people randomly to say that it's random. Okay, if I wanted to make you guys a random sample, I would have to say, okay, everybody has a certain number that you're given. Let's say I'm going to give you a 2-digit number. It doesn't matter if these 2-digit numbers are sequential or just all over the place. If we wrote down your number on a slip of paper, that's an identical slip of paper, and we have not changed that slip of paper at all, and then I kind of shuffle it around and then started drawing a certain amount of pieces of paper out of there, that's not even random. How I have to do a random sample and pick a random sample from identical pieces of paper, I would have to use something called a random number generator. You can find random generators online, okay, which are relatively random, but they're not perfect. They also used to have in statistics textbooks lists of random numbers. And then what I would do is so let's say I was using a computer software to give me a random number. So I'd be like, oh, 56 came up. I'm going to pick the 56th piece of paper out of this thing, which didn't work. So what I'd have to do is to say, okay, I want my random sample, my random number to come out with 30 numbers. So then I'm trying to come out with 30 numbers and try and select a certain amount. Okay, the individual selections in sample, this is random sampling, were randomly chosen from the population of interest. It implies that each individual in the population of interest had an equal chance in the sample. Okay, I have told you this, that I have won every year that at our end of the year school banquet for all the teachers and staff, I have won every year. Okay? Basically, how they do it is once you're there, they're like, oh, Chris Stirrup's here. They take that piece of paper and they give it to me and say, here's your piece of paper. Go put it in that box over there. And I cheat. I crumple up my piece of paper, then I unfold it so it's all crinkly. So when somebody's hand goes in, the probability that they're touching a flat sheet of paper versus one that's crinkled, the crinkled one has a higher probability of being picked because they're going to feel it first. And they draw it out. I kid you not. I continue to win over and over and over again. I teach with other math teachers who understand statistics who don't do this. Stirrup cheats every year and wins. I'm sorry. You guys might think horribly of me. And you might say to me now, Stirrup, aren't you worried you're going to jinx it? I tell my class this every year. So if I jinxed it, I don't know what's happened. Okay? So independence is something else. Independence. And these would be good things that when you're doing your full sheet of paper for the test, you want to make sure you have these definitions down. Independence is the probability of an individual's response was unaffected by the conditions in which other selections were made. Because I crumple up my piece of paper every time and I throw it in there, there is not independence that's taking place in that box of papers. Okay? Slips of papers that has all the people's names on it. Okay? Independence basically means if my district or if my school wanted to make it fair, they would say, oh, okay, Chris Stirrup, you're not number 27. Okay. Now I can't interfere with it because the random number generator they're going to use, if they pick number 27, it's just by chance. It's not because I influenced the statistics of it. Okay? And then number 3 says, sample size large enough. Small sample sizes suffer from a high sample-to-sample variability. Okay? You do not want to draw conclusions about a population based on a small population. Okay? So what that means is, let's say we have 30 people here. Okay? And I did everything right. I have independence. I gave everyone a random number then I pick only one random number. If I picked one person in this class and said, that's what I'm going to choose to influence everybody else, do you think that only one person in that selection would be fair? Let's say I was going to base it on that one person I'm going to pick is going to be what the grade that everybody gets in the class. Okay? Whatever that student's grade is at the time is what everyone else is going to get. Now, some of you might say, dude, I'm getting like low B's, high C's in Stirrup's class, and I know there's A's in here, so yeah, heck yeah, I want to be in that. Well, the person with the A's and B's might not be like too willing to have one person dictate a conclusion based on a single person. This is where so often statistics gets messed up. Okay? People sit there and see something that took place. It's a very, very small sample, and they're then going to apply it to the entire population. Okay? It's really hard to do, but you have all been impacted by certain things that you've seen on your social media. Agree? Wow, that's messed up. That shouldn't happen. Wow, if that applies to everybody, that's horrible. Well, you're looking at one story that was pushed out to you by certain characteristics of what your search projects have been on your phone that have now given you that piece of information that a lot of times the general population is going to make a conclusion based on that one piece of data that came on social media because somebody saw something that happened and when they were at the grocery store, and now they want it to apply to everybody. Okay, I'm not saying that there aren't bad things that take place in the world. They're 100%. There are very bad things that take place. If you were, let's take a situation. Let's say you are going to take a flight from here to California. You're waiting at the airport, and on the news, the news channel that's on, there was an airplane that crashed in the United States. Are you worried your plane's going to crash? Well, yeah, you're going to start thinking about, oh my gosh, that's absolutely horrible. Boy, I hope that my plane doesn't crash. But because there was a plane crash that took place somewhere in the United States, does not impact that your airplane is going to crash. But there have been times that certain bad events have taken place and people have chosen not to do something. I want to cancel my flight today because there was a plane that crashed. Oh, okay, I understand. The airlines will indeed accommodate you, but you start having emotions that carry into your decision, which don't weigh into what statistics actually is. Okay? Don't get me wrong. I don't want anyone to be in an airplane crash. I don't want to see airplanes crash. I don't like that happens. Okay? We all hear that car accidents happen all the time. Does that prevent you from driving? Okay? So when you know that car crashes are taking place every day, it doesn't really go through your mind too often that, oh, I'm not going to drive then because a car crash took place. But because you don't fly as often as you would drive your car, the impact of hearing about an airplane crashing is going to impact your decision on you flying. And it has nothing to do with it. It becomes an emotional factor. It has to be taken out of the equation. Okay? Consider the following example. Let us assume that cholesterol levels nationwide have an average of 195 and a standard deviation of 25. Okay? So we've heard this information before. Of course, we would never simply know this. We are pretending that we do for the purposes of the example. The medical research collects from a database of 2,000 patients at a local Denver hospital. From this group of patients, this person calculates that the average cholesterol level is 192 and the standard deviation is 21. Okay, so basically, they have this that they're giving you based on some sort of data, and they have this that they're giving you based on some sort of big database. And then a local hospital redoes it, and they check 2,000 people, which seems like an awful lot of people to check, and they find that the local hospital has 192 mean and yeah, that's right. And then a standard deviation of, did I do those right? Yes. Okay. Sample standard deviation of 21. Okay? So, if you look at the two means, are they close enough to each other that you feel that the original might mean something? When you look at the two standard deviations, are they close enough to each other to say that they're pretty good? And it all depends. Okay? Now, what are a few things that are kind of sticking out to you? That you have the population mean, the sample mean, the population standard deviation, the sample standard deviation, and the sample standard deviation. Okay, population standard and sample. Okay, primary goal, researcher hopes the sampler is representative of the population. In other words, the sample of 192 is a reasonable estimate. Okay, so things that are going to take place here. Okay, this is a good size sample. Okay, 2,000 people that you've collected data on is a good sample. Okay, now, here's information that you don't know. If you read that paragraph again, does it say that we had a random sample? Is that 2,000 random? Is there anywhere in there that says that it was random? No. This hospital just took 2,000 people's records and said, look what we showed. Okay? So this is not random. Okay? So right now, we can start discrediting this because this is not random. It did not say it was a random sample that was taken. Okay? If they put the words in there that a random sample did take place of 2,000 people, okay, that is a different story. Now, other things that stick out. This said a local hospital was how we got the data. Okay? Friends, this is just as bad as the guy or the girl or the person who is standing outside of the mall down there in right by Douglas County, 25 and 470. You know what I'm talking about? Okay, you have someone out there who's collecting data of people at a mall. Okay, even if they were like, they had like a random number generator, so I'm going to pick every 5th person, and I'll pick the 8th person that comes next, and then I'll pick the 72nd person who comes in next. Though they are trying to get a random sample of people, we're talking about people at the mall. If I was trying to collect data from people at the mall, can I apply that to the entire nation? And the answer is no. Local is not a good way to sample for an entire population. Okay? Now, if you were trying to collect information for south suburbs of Denver, that might be a little bit more accepted, because if you live in the suburbs in South Denver, you might be going to that mall occasionally. But then you got guys like me that aren't allowed to go to the mall anymore. Okay? I'm not even allowed to go to the grocery store with my wife anymore. Okay? Because I play around. You know, I go to King Soopers with my wife and I find the grossest stuff. I find the pickled pig's feet. I grab a couple jars and I'll start putting them in other people's shopping carts. And my wife gets all mad at me because I'm screwing around. I grab the Depends undergarments, you know, for if you sneeze or you laugh or you cough and then you pee yourself, you wear these undergarments so it doesn't look like you peed your pants. I put those in other people's grocery carts as well. I'm a bad person, but I find entertainment in other things. So now you have to eliminate me from collecting data because I'm not allowed to go to these places anymore, based on what my wife has told me. When I go to the mall, I purposely walk into people, like I'll walk towards people, where I can see that we're walking on the same path, so I will continue on the same line of path and get in their way. I like doing stuff like that. I'm sick, I'm demented, I don't know, I think I got my head hit too many times as a kid. I didn't wear a helmet when I rode my bike. I mean, there's all kinds of bad things. Okay, so primary goal: the researcher hopes that the sample is representative of the population. In other words, the sample mean of 192 is a reasonable estimate of the population mean. Then we look for signs that the sample does not represent the population at large. Is there any reason to suggest that this estimate wouldn't be trusted? And the answer is yes. The sample is quite large. We pulled from a database at one local hospital. Okay, if the goal is to estimate the nationwide mean and cholesterol level, they need to randomly select people from the entire population of interest, so everybody from the United States. So there's a big concern that does not mean the estimate is wrong, possibly. We have now reason to doubt the estimate does not make for strong evidence. And then the population interest. They continue the research, describe their sample thoroughly. In their conclusion, there is valuable things learned, and future researchers might repeat the study with different sample and expand on this research. Okay, so what this basically talks about: sample size, is it large enough? Yeah, looks good. It's a good number. Okay, if you collected 10,000 pieces of data or 2,000 pieces of data from a random sample of people throughout the United States, that's probably a good amount of people. But because we took those 2,000 pieces of data from a local hospital and it wasn't a random sample, it is a no-no, okay? But still, I said that people over and over and over again will sit there and say, oh, yeah, my data is good, therefore I'm going to accept it, okay? You feel okay with it? Does it make sense? All right, so let's hit page 73 and page 74. And we'll do that. And I apologize, I don't have our test graded yet. Okay, I hopefully it will be done this afternoon. I hope. I'm hoping, praying. Okay, but you never know. Okay, so we'll take a look at that. So that's what I got for you.